In this video, we shall solve some exercises in parabola. In particular, this is about problems related to parabolic mirrors. So this is the problem. A parabolic mirror is 32 centimeters wide and 10 centimeters deep. How far from the surface of the mirror will the reflected light rays meet? The reflected light rays will meet at the focus. So this is the sketch of our problem. You have there a parabolic mirror. So this is the surface of your parabolic mirror. Light rays will strike that mirror and they will be reflected back, and all these rays will meet at a certain point, at a common point. That point is what we call, and what we had been calling as, the focus. The challenge to us is find the distance of your focus from the surface of your mirror, or in particular, find the distance of your focus from the vertex of our parabola. So parabolic mirrors are often used in some recreational experiments such as this. So they are using the principles of a parabola to harness the energy coming from sunlight and focus them at a certain point, at a common point. So here, your light rays meet and this sausage gets cooked. Parabolic mirrors are also the principle that is being used in a parabolic satellite dish. So this is a satellite dish which is in the shape of a paraboloid. By the way, a parabola is a curve on your Cartesian plane. So if you are talking of a counterpart of a parabola in a three-dimensional space, you call that a paraboloid. So the same principle applies to this parabolic satellite dish. So this dish, you probably have this in your house. Maybe a smaller version of this technology in your house. So this dish will receive radio waves, and those radio waves will be reflected back to a common point. And from that common point, the light rays from that point will be transmitted to a receiver, and that can be your radio or maybe your TV. I also heard and watched a program, a documentary about the application of the parabolic mirror during the war between the Romans and the people of ancient Greece. And it was Archimedes who was credited to have invented a parabolic mirror such that using that mirror they can set these ships on fire. Their mirrors were actually not made from glass. They were made from sheets of metal. So they polished the sheets of metal so that they are capable of reflecting light like mirrors do. So let us solve this problem. The problem is about finding the focus, in particular, the distance of your focus from the vertex. So this is what we shall do. We shall use the Cartesian coordinate system. We will put our parabola in standard position so that the bottom of our parabola will coincide with the origin. So our vertex here is 0, 0. Now, so imagine your parabolic mirror. Okay, it has a rim. So the rim is in a shape of a circle. The diameter of that rim, okay, is 32 centimeters. That is how you interpret this. 32 centimeters wide. So your parabolic mirror, its rim is in the shape of a circle. Its diameter is 32 centimeters. From that one to that one is 32 centimeters. Well, what that means is from this part to that part, its length is 16 centimeters. From this one to that part, it is going to be 16. And if we shall use the coordinate system of our Cartesian plane, that one would have the coordinates of negative 16, okay? And that one would have the x-coordinate of 16. Our parabolic mirror is 10 centimeters deep. That means the distance of that point from the plane below is 10. Okay, so solve for A. Okay, so we can derive the equation for this parabola and then we shall solve for A. So how do we do that? So this one is a parabola that opens upward. Its axis is vertical. So that means its form is something like this. X squared is equal to 4 times a times y. What is a? Okay, so what we shall do is we can substitute these points to x and y. Because these points lie in our parabola, they must satisfy our equation. So what is a? A is 6.4 centimeters. So our focus is located somewhere there. Our focus is located somewhere there.